Okay, in today's notes, we are going to go over topic 1.4, example 1 and 2. So the learning target here is I can rewrite and use literal equations to solve problems. So on Envision, it says one definition of literal is of relating to or expressed in letters. So we're going to have equation that has most of the letters. It says a literal equation is an equation expressed in letters or variables. So the first thing I want you to remember is that our goal is still to solve for a variable. Now you have to pay attention to which variable that you are going to solve for. And you still need to do the inverse operation. So we're still going to start with adding and subtracting and move all the way up to multiply, divide, all that good stuff. So in the first example, it says Janet wants to calculate the time it takes to earn a certain amount of interest on a principal amount in investment with simple interest. So what you need to know is that this is our equation, I equals PRT. So capital I stands for interest, P is the principal, R is the rate, and then T is the time. So if you go I equals PRT. Now notice in this it says she wants to calculate the time. So in this case, our time is T. So you have to ask yourself, how is P and R related to T? What's happening there? And it's related through multiplying. So we learned, since there's no adding or subtracting, we can skip this step. We learned the opposite of multiplying is division. So we are allowed to divide by P and R. Now PR over PR goes away, and we are left with T equals interest over principal times rate. So that's actually going to be our answer. The reason why it's our answer is because we have T by itself. We have it isolated. The reason how we knew that we wanted T isolated is because she wanted to calculate the time. So you will never have to memorize this formula. I will give you the formula. I'll say I equals PRT. You will have to know if you have to calculate for the time, for the principal, for the rate, etc. So you want to make sure that you read the word problem carefully. So the try it. The try it says, what equation can Janet use to calculate the principal amount? So once again, you do not have to memorize this formula. Interest equals principal times rate times time. You just need to know what we're looking for. It says that we're solving for the principal, the P. So we are going to isolate or get the P by itself. Once again, in this formula, we're multiplying by R and T. So if you look at PEMDAS, there is no adding or subtracting. So we can cross that out. Opposite of multiplying is dividing. So we're going to divide by RT. So then in this case, I over R times T equals P. I know that that's all I have to do because she asked us to solve for principal. Now in example 2, we're going to have to do something when we manipulate or change the literal equation. So in example 2, she's asking for something else. So she's asking for, it's a different situation. So it says in a half hour, sorry guys, I have to erase this first. So in a half hour, Sarah is meeting her friends at the lake, 6 miles from her house. At what average speed must she ride her bike to get there on time? So there's another formula. It says solve the distance formula for R. So the distance formula is D equals R times T. So distance is our D, R is our rate, and T for time. Now it tells us what we're solving for. Solve for R. So I'm going to highlight the variable that I want isolated. Once again, follow PEMDAS. So there is no adding or subtracting in this case. So we have to divide by T because it's being multiplied. Do you undo multiply, you divide. So now we have the formula R equals D over T. So this is going to be very useful in the actual problem. So it says find the average speed or rate. Notice we're trying to find rate at which Sarah must ride her bike. So there's key information here. It says in a half hour, so we know our time is 0.5 hours. We also know that the distance is 6 miles from her house. So MI stands for miles. And now that we have our equation isolated for R, we just plug in. Make sure you plug in the right location. My distance goes on top, and my time goes on bottom. So then it's 6 miles over 0.5 hours, and that will get us our rate. Which if you put this in your calculator, 6 divided by a half hour is 12 miles per hour. So then a sentence would be, her average rate is 12 miles per hour. Now in your turn, you're going to use the same formula. It says, sorry guys, there we go. All right, it says Sarah is now going to the store 2.5 miles away. So they're giving us our distance. So that's 2.5. Now, 15 minutes away, you have to be careful because we're talking about in hour time, but they gave it to us in minutes. So if we split up our clock into 4 chunks, this would be 15 minutes, which is also 1/4 of an hour. How do you write 1/4? You write it as a decimal. So it's 0.25 hours. So now it's asking us, what is the average speed? So we have that distance equals rate times time. We need to solve for R, which is our average rate. So then we're going to divide by T. So now we have R equals D over T. And now we can plug in like we did. So our distance is D, and our 0.25 is our time. So 2.5 miles over 0.25 hours. If you put that into the calculator, it will give you 10 miles per hour. So the average rate would be 10 miles per hour.